Hello and welcome to a new video. So today I'll show you some updates on fastmeshapi, and let's start immediately. Here in the top navigation bar, we still have the same menus, but the connection submenu now is reactive, which means that if the server gets disconnected for some reason or your browser cannot reach the server anymore, this menu is going to change here. So if you see, every time I open the menu, a new GET request is done on the connections endpoint. And we have it here as well in the FastAPI documentation. Okay, so this endpoint just returns a boolean. So it returns true when the server is connected to the Meshtastic radio and false otherwise. So in this case, we are connected to the radio, the packets are coming in. So this is working as expected. Before, this wasn't happening. It was just a button which could connect and disconnect, but it wasn't reactive. So when the browser could not reach the server, this text here didn't change, and so it was confusing. And this is the first update. The second update, which is indirectly connected to this one, is that if I stop the server like this, okay, you can see what's happening. So the browser is detecting that the connection between itself and the server was interrupted, and so it's going to retry every 5 seconds to reconnect to the WebSocket. Now, if I restart the server, this window should disappear automatically eventually. It should reconnect to the server automatically. You see, connection open, WebSocket, okay, so as I said, the two things were connected, so now we can see the menu here that it's not connected anymore, and in fact here it's asking me to connect to the radio. So this wasn't happening before. Now let's see another thing. When I stop the server like this, I click here. See, unable to contact server. So this is another detection thing I added. Now it should, okay, if I close and I reopen, see, it's working as expected. Okay, if I connect, eventually all the new packets will be received, will be downloaded from the radio. Okay, this is how the drop-down menu is implemented now. I changed this toggle function because before it was just a boolean and now it's a real function. And there is a boolean here to check if the drop-down needs to be open or not. And of course, to toggle it, you just put a not in front of the variable and save it in the variable itself. And then here it means that when the dropdown is open, we go and check the connection to the radio, which is here. So we have this other function called check connection, which is very simple because we go to the endpoint I showed you before in the API. And we set is server connected to LoRa radio. Yeah, it's a bit long, but I think you can understand what it means. And we set it to true or false depending on the response here. In case the server is not reachable, we don't know if the server is connected to the radio. So we set the status known to false. And when we know it, we set to true. Based on that, we set the various items in the drop-down menu. When the status is known and disconnected, we have these labels here. Disconnect label when it's connected and when we know that the server is actually connected to the radio. The connect when we know that the server is not connected to the radio. And in all the other cases, we just say unable to contact server, as I showed you before. Because maybe, for example, if your computer is not connected to any network, this will show up anyway. So it's not only the case when the server is not running, but also the case when your browser cannot reach the server for any reason. About the WebSocket connection, the one I told you, when you interrupt the server and you get this message here. Now that is handled by several Svelte components. I had to set up some different modules. Okay, we have this connect WebSocket function, which is a little bit reworked from the previous videos. So the structure is similar, but now we have more variables to check the state, more error checking in general. We also have the disconnect function, okay, and then we export these variables, which are imported from the home.svelte component. And if for any reason, as I showed you before, the WebSocket closes, there is the retry strategy. So we set the WebSocket connected to false, so the home component is going to pick up that the WebSocket is closed and is going to call the modal, the red modal I showed you before. And then we try like this every 5 seconds. This is like a recursive function because connect WS is this one, so it is a recursive function. Every 5 seconds is going to retry to connect to the server. This is the WebSocket reconnection modal, which is very simple. Here there's not much to show. Effectively, we're just passing the isOpen variable to know when the modal needs to be open, and these are all Sveltestrap components. So this closes this first part of updates. And then we have the map. But before talking about the map, I fixed the packets, the live packet table. So let's reconnect again to the radio. Yeah, you can see here when you reconnect it's going to do a lot of requests, but it's working. Okay, so now every time a new packet arrives, it's not going to do 100 requests, but just get the subtable, only one request for each new packet, the base packet and the detail here. Okay, so this was fixed, and then this map is not showing the position of all the known nodes, but it's just showing in the last 100 packets, because here we still have a table with 100 packets. It's limited to 100 packets, so these pins on the map represent the position packets of the last 100 packets in total. So these are, I think, less than 20, and they change every time a position packet gets in. Yeah, at the moment this is very rudimentary, but yeah, this is just the first step. But if you're curious about what this map is, I can just show you the code. So this map is a Svelte packet maplibre. Okay, Svelte-maplibre is this project here, which is an alternative to Leaflet. You know Leaflet. Leaflet is the classical way to incorporate OpenStreetMaps on websites, but I found this one, it seemed interesting. So yeah, there are lots of examples here. I used this one of the pins. You see, it's more or less the same as I did on the map. See. Yeah, there are some differences between maplibre and Leaflet. Essentially, maplibre requires WebGL and it uses vector tiles instead of pictures or images, which Leaflet does. And of course, using WebGL instead of simpler technologies is going to be heavier and less compatible than Leaflet, but for this use case, I think it's good. How this works, you set up your maplibre component. Then you have a for loop with all the markers. Each marker has a latitude, longitude, label, and name. You have to set up the pop-up for each marker, and the pop-up is going to get the name from the marker itself here. These are like attributes of the marker object. The marker is a list, and each element of the list has longitude, latitude, like this, the label and the name. If you want to see this example here, okay, this makes it very clear on how to set up your markers. Okay, so these are the new feature and fixes. Okay, so if you like this video and if it was instructive for you, put a thumbs up and subscribe, and I'll keep you updated about this project. And as always, bye bye.